Alright, so here's your notes for section 7.1, and this is exponential growth. And exponential growth stuff is really, really cool. It's a great way to model money, and who doesn't like to talk a little bit about money? And it's this blue curve up here in this corner. So up here is where we're looking at. And the blue curve is what an exponential growth curve looks like. It grows so fast, exponential growth. And we're taking the parent function for this guy to be f of x is equal to b to the x, where b has to be greater than 1. And here it is over here on the left side of your page also. And so what we're going to do is we're just going to graph that guy and have a look and see what it looks like. And then we'll go from there. So oh, by the way, let's talk about this real quick. The domain and the range for this guy. So when you look at the domain and range, you'll notice that the graph is entirely above the x-axis. And so we would say for this particular graph, let's put it right here, that the domain and the range, for this particular graph, you'll notice that it's all above the x-axis. So the range is going to go from 0 to positive infinity. Okay? In the x-axis, it's like a horizontal asymptote there, so our blue line will never cross the x-axis, and since it doesn't cross the x-axis, we're only using positive values of y. It will never touch the x-axis, so we can't include the 0. And then if you look at that blue line, it's pointed towards negative infinity on the x-axis, and it's pointed towards the right, towards positive infinity on the right side of the x-axis. So the domain for this guy is going to go from negative infinity to positive infinity. Okay, so that's the domain and range for the parent function for exponential growth. Well, what does this look like in real life? Well, let's just have a little peek. You're going to make a graph just like you did back in the 7th grade, and we're going to pick some values of x. So let's pick, like, say, negative 2, negative 1, 0, 1, and 2. And we're just going to put these into our problem and work it out. So if I've got the graph y equals 2 to the x, and for this first guy, it's actually going to be 2 to the negative 2. And 2 to the negative 2 is actually 1 over 2 squared, which is actually going to be 1 over 4. So that's my first point, negative 2 and 1/4. And then I'm going to look at this again at negative 1. So when 2 is negative 1, that's the same thing as 1 over 2 to the first, which is the same thing as 1 over 2. So at negative 1, I'm at a half. And then I'm going to put in 0. And remember, anything to the 0 power is 1. And hey, guess what? We saw that over here in this original graph. So that's an interesting thing. Don't ever forget some of those more simpler things. Sometimes I come back frequently to visit. Then when I look at 2 to the first, it's the same thing as 2. And then when I look at 2 squared, that's the same thing as 4. Alright, so I've got some xy points that I want to graph here. And when I do that, I'm just going to go negative 2. So I did a pretty good job here blending this guy up. So negative 2 and 1/4. That's really close to the x-axis, but not quite. Negative 1 and 1/2. So I go to negative 1, and that's not quite right either, but a little bit taller than that. That's a little tall. And then I'm going to go at 0, I'm at 1. And then at 1, I'm at 2. And then at 2, I'm at 4. So this graph is going to look something like this. And what would the domain of this graph be? Well, any x value at all. So it goes from negative infinity to positive infinity. And the range never crosses the x-axis, so it goes from 0 to positive infinity. Remember, with domain and range, it's where you start and where you stop. Okay, so let's graph a few more of these bad boys. And remember, these are all related back to the original parent graph of f of x. I'll just write it right here. Let's see, purple. F of x equals b to the x. Okay, these all kind of go back to this guy, except now we've got like 1/2 or 4 to the x. Well, no big deal. you're still going to make a table of points. -2, -1, 0, 1, 2. And you're going to do that for both sides. So something like this. Okay. And what you're going to do is you're just going to do your math, just like we did on the very first problem. So when I look at y equals 1/2, I've got 1/2 times 4 to the -2. Well, remember, the only thing getting -2 as an exponent is 4. So this is going to be 1/2 times 1/4 squared. Okay, 4 squared is 16. So this is going to be 1/2 times 1/16, which is 1/32. So that's the first guy. Then do the next one. 1/2 times 4 to the -1 is the same thing as 1/2 times 1/4 for the first, which is 1/8. And then 1/2 times 4 to the 0 is the same thing as 1/2 times 1, which is 1/2. And then when you put 1 in, you're going to have 1/2 times 4 to the first, which is the same thing as 1/2 times 4/1. Now remember, you're not cross-multiplying here. There's no equality. You're just multiplying fractions. And when you do that, you multiply straight across on the top and on the bottom, and then reduce so that it will be easier to graph. So there's a 2. And then plug in that last guy, 1/2 times 4 squared, which is 1/2 times 16/1, which is 8. Remember, you want to reduce these. And so you'll notice that this graph grows really quickly once we start getting to those positive numbers. So let's take a look at what that graph might look like. Okay. So I'm at -2, 1/32. So I'm at -2 on the x-axis here, and I'm just barely above the x-axis. I don't even know if I can get that close. And then when you're at like -1 and 1/8, that's just, barely above the 1/32. So that guy's there. At 0, you're at a half, so you're about here. And then at 1, you're at 2. And then when you're at 2, you're at 8, way up here. So this graph just takes off. And again, on this guy, the domain goes from -infinity to +infinity. And the range goes from 0 to +infinity. So there's that guy. On the other hand, this other graph over here with the -5/x to the power, this guy's going to look a little bit different. And so let's take a little quick peek at him. Well, let's find out these points first. We'll do it in a different color so it stands out a little bit. And so when I go for -2, I've got negative, and then 5/2 to the -2. That's the same thing as -2 squared over 5 squared. Remember that negative exponent changes both those guys inside upside down, which is going to be -4/25. Okay. The next one is going to be -5/2 to the -1, which is -2/5, which is negative 2/5. Anything to the 0 power is going to be 1. In this case, a negative 1. And here's why. Negative 5/2 to the 0 is negative 1. Okay? And then put a 1 in there. So negative 5/2 to the first is the same thing as negative 5/2. And the last one is negative 5/2 squared, which is negative 25/4. And notice that when we go from 1 to 5/2 to 25/4, all of those numbers are getting bigger, 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 bigger. So when we graph this, notice all of my y values are negative now. So I'm graphing under the x-axis. And when I'm at negative 2, I'm at negative 4/25. That's like almost 1/6. So I'm at like negative 2, negative 1/6. Then I'm at negative 1 and 2/5. That's a little less than a half. Then I'm at 0, negative 1. Then I'm at 1 and negative 5/2. That's like 2.5. And then I'm at 2 and 25/4. That's 6.25. So my graph is going to look like this. Well, what's the domain on this guy? And again, the domain goes from negative infinity to positive infinity. But guess what on the range? The range is all below the x-axis. So it goes from 0 to negative infinity. Okay, so here we've got a new exponential function to graph, and this time we've done a couple things to it. We've multiplied the whole thing by 4, and we've got the x minus 1, then the exponent, a minus 3 at the end. So let's just look over here at this guy. Whoa, that's not right. Let's just look over here at this guy. And remember that when we were talking about functions and how they moved, remember if we do something to that x, whatever we do to x, we're going to go the opposite. So this guy right here, we're going to go the opposite of what it says. So if it says x minus h, what this really means is we're going to go h units to the right. And again, this is just like what we talked about with some previous graphs. If the guy is looking at the k part, which is right here, then this is going to be k units up if it's written just like this. So basically what we need to graph, if we look back at our original function way over here on the left, we need to graph y equals 4 times 2 to the x. And then what we're going to do is we're going to look at this part right here, this x minus 1. And that tells us that we're going to move 1 unit left, or I'm sorry, 1 unit right. And right here where it says minus 3, we're going to move 3 units down. Okay, and so basically we're just left then with the one thing to graph. And so let's just set up a quick table of points. And let's do some math. So we're going to have 4 times 2 to the negative 2. That's the same thing as 4 times 1 over 2 squared, which is going to be 1. Then we're going to have 4 times 2 to the negative 1, which is the same thing as having 4 times 1 over 2, which is 2. Then we're going to have 4 times 2 to the 0, which is 4 times 1, which is 4. Then we're going to have 4 times 2 to the first, which is 4 times 2, which is 8. And then we're going to have 4 times 2 squared, which is 4 times 4, which is 16. So there's our graph. And then what we're going to do is we're going to take this graph and we're going to move it 1 unit to the right and 3 units down. And so we've got this graph. Let's see if I can get it. Negative 2, 1, and negative 1, 2, and 0, 4, and 1, 8, and 2, 16. So I have a graph that looks like this. And that's this part right here, 4 times 2 to the x. And so what I want to do is I want to take all those points now, and I just want to move them 1 unit right and 3 units down. So, you know, instead of this guy being right here, he's going to go 1 unit right and 3 units down. So instead of being at 0, 4, he's actually going to be at the point, let's see, what would that be? 3 units down, 1, 1. And then this guy right up here, instead of being the point 1, 8, he's going to move 1 unit to the right and 3 units down. So he's 1 unit to the right and 3 units down. So he's going to be at the point 2, 5. And so it's basically the same graph. It's just been moved 1 unit to the right and 3 units down. So you're still going to get that same exact graph. It's just going to be moved just a little bit. And so when you can start recognizing that, it makes a difference on graphing these kind of problems. Okay, so compound interest, this is where everything gets really, really fun. So compound interest has this formula right here. The A equals P times 1 plus R over N to the NT power. And this is a really cool formula. And it tells you how much money you can earn back for different things. And the A part of this, the A part is the amount you earn. Okay? It's the amount of money earned. P is the initial investment. A lot of times you'll hear P referred to as principal. R is the interest rate. N is the number of times you compound the interest per year. And T is time, usually in months. So if you deposit $4,000 into an account that pays 2.92% at annual interest, find the balance after 1 year with interest compounded quarterly. So when they say interest compounded quarterly, they're telling us that N equals 4. And then with interest compounded daily, they're telling us that N equals 365. Okay? And for 1 year, that's going to be 12 months on both. And the amount we don't know, the principal for both of these, the principal that we're going to put in is going to be $4,000. And the interest rate is 0.0292. All right, so there's your setup. So what is your equation going to look like? Well, on that top question for quarterly, your equation looks like this. A equals the principal, 4,000, times 1 plus the rate, 0.0292, over 4. And then the NT is going to be 12 times 4. On the daily, you're going to have 4,000 times, you know what, this should be time in months, I think. I'm going to switch that up. Time in months needs to be years, because this is going to be how many times we do something. So I'm going to take this 12 right here and make it a 1. So this is going to be 1 times 4. And so down here I'm going to have 4,000 times 1 plus 0.0292 over 4 times, and then again it's just 1 year, but you're doing it 4 times, or daily, so it's going to be 1 times 365. And so when you're talking about this, think about your exponent up here. Think about that exponent as the number of times that we're compounding the interest overall. So if we're doing it quarterly, we're doing it 4 times per year. If we do it quarterly per year for 15 years, it would be 4 times 15. So I misspoke when I had months up earlier. And then what you'll need your handy dandy calculator out, and you'll just need to punch all this stuff in. So I'm going to punch in on mine right now. 4,000 times 1 plus 0.0292 divided by 4, and raise all that up to the 4th power. And that gets me a grand total on quarterly of $4,118.09. And then on the next question, which is the same thing, but now we're compounded 365 times 1. Whoop, I typed it in wrong. Gets us 4,018, $4,118.52. Big difference for compounding daily. Where it really shows up, though, is if you look at daily and quarterly and yearly and stretch that out to 20 or 30 or 40 years. So anyway, there you go. There's your compound interest.